For this problem, we have the statement, the quantity P varies inversely as the square of V. Using the letters P, V, and K, form an equation connecting the quantities P and V. Notice that what we have here is that the quantity P varies inversely as the square of V. But using the letters P, V, and K, form an equation connecting the quantities P and V. Notice that K was not initially given in the first statement of the problem. For an inverse variation, there's a relationship between one quantity and the inverse of the other. The inverse referred to is the multiplicative inverse, which is also called the reciprocal. There's a relationship between one of the quantities and the inverse or reciprocal of the other. We have there P varies. P varies. Well, of course, we could use that symbol to mean P varies, but in science, in mathematics, in general, that symbol is the proportionality sign. The symbol is called the proportionality sign. We say that P is proportional to whatever there is to follow. So P is proportional to whatever is there to follow. And what will follow? Right there we have following, and of course we are saying inversely because it matters whether it varies directly or it varies inversely. Now, it varies inversely. What does that mean? Well, we discussed that before, that for the inverse relationship, we have the relationship is between one of the quantities and the inverse of the other, and the inverse that is referred to is the multiplicative inverse or reciprocal. So we start by implying that we are going to have the inverse or reciprocal of one of the quantities. The inverse relationship is shown by the reciprocal of the other quantity. But what is the other quantity? The square of V. So the other quantity is the square of V. The quantity P varies inversely as the square of V. So we have there the square of V. There is an inverse relationship between P and the square of V. Because there is an inverse relationship between P and the square of V, the expression will contain P and the inverse of V squared. What do we mean the inverse of V squared? The multiplicative inverse, which is the reciprocal of V squared. It is not inversely proportional to V, but the square of V. And that is why we have V squared applied there. So V squared is therefore applied. The expression that we have is at best descriptive of the relationship between P and V. So there is a relationship, and we can see that there is an inverse relationship between the quantities P and V, to the extent that P is proportional to the inverse of V squared. For the expression to be quantitative, we need equality and a quantitative link between them. Because as we have them right here, we cannot quantify anything. So we cannot match them numerically. Because we cannot match them numerically, then we are unable to determine values of P and corresponding values of V. Therefore, we need to take this a little bit further in order that we can have numerical values and that they will make sense, and what we have for P will be able to be substantiated as being related to a particular value of V. For the expression to be quantitative, we need equality and a quantitative link between them. The link is provided by a constant of proportionality or constant of variation. And that is where this K comes in. So this K is a constant of proportionality. It is a constant of variation which links P to V. Or we may say P, if you want to be all-encompassing, we may say P, it links P to the inverse of the square of V. In applying that constant of variation, it is not only possible, but it is certain that we will be able to find P and corresponding values of V. So that constant of variation or constant of proportionality will cause equality between the left-hand side and right-hand side to be possible. Therefore, this mere proportionality sign may be replaced by an equal sign when the constant of variation or constant of proportionality is applied. So what we have there, we replace the proportionality sign with the equality sign, with the equal sign, and also we ensure that there is a constant of proportionality. The expression now makes sense numerically. Here we are capable of finding values of P and corresponding values of V. But we will not be able to do that if we do not have a value for the constant of proportionality, which we will take a look at in another problem. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.